All right, so I just started playing around with the Super Jewel Ringer Looper circuit, Lasersabers Looper circuit, and I was watching a few videos trying to figure out what was going on with it and what other people were kind of results other people were getting, and it was pretty damn amazing. Um, Now, one thing I've noticed is Laser Saber always gets the kind of results where I already just assume off the bat I'm not gonna be able to come anywhere near, which is the case right here. But I can say that I would consider this a successful near replication simply for the fact that I feel like it's the best um, working oscillator that I have to date that will run a little LED off such low power, which I thought was really, really awesome. Um, Now there was some changes I had to make because I didn't have everything on hand, and basically what I ended up with was this is his circuit the same way he has it wired, except I've got a different transformer, and I ended up having to use I wanted about a mega ohm pot on there in place of the diode, but I didn't have that, so I had to use these two 250 kilo ohm audio tapers. Those are in series to try to give me about half of a mega ohm adjustability. And what that is, that's in place of that germanium diode. And over here, see, I have a nice air capacitor. Now that is in parallel with my resistance. So this is how I'm trying to set up my little tank, my little tank circuit here, and it seems to work out fairly well. I've got my radio in the background here, lid motor style, so you can hear what's going on. Um, and what I have on the input right now is it's a 100 microfarad uh, flash capacitor. See if I can zoom in on this sucker. You see, it's a 100 microfarad photo flash cap, 330 volts. So it's a pretty big cap. Um, I've had this for a long, long time. Used this cap for a lot of things. I just happened to pull it out of the stash, but it's got about 6.5 volts in it right now. Go ahead and just juice it up a little bit more per the orthodox battery tap style right here. All right, so bringing it back up about 9.5 volts. Just charge this 9 volt. And first, I'm going to explain real quick what I did here with the transformer. Um, I basically have it wound on a bobbin, and I had a toroid that I realized was the perfect size where I could slide the bobbin inside the toroid to try to emulate a pot core because I don't have any more pot cores. And I figured that would work out pretty good. Wouldn't be quite as efficient, but I noticed I can. It generally doesn't make all that much of a difference. I could leave it on or take it off. It improves the efficiency very, very slightly. Not enough for me to really care about. I could lose it right now and I wouldn't care. But basically what I'm going to do real quick is show how the circuit will run per as I have it wired. So right now I've got my resistance off. This circuit will not fire up with just this capacitor. See, I can touch it different ways every now and then, and I'm just going like this, and it'll come on and it'll drain. It's actually draining from the cap. This thing is very iffy when it comes to capacitance, which is what I'm about to show. So let me charge this freaking cap again. All right, so we're charged back up in the cap, and what I'm going to do is I'm going to make contact with basically my tank resistance here. It's not hooked up, it's open, so I'm going to touch it, make the connection, and just watch the do it back here. Watch the voltage. So you see it basically just kind of shot it all out, drained it super quickly, which before I was using this 10,000 microfarad cap, and it actually ran decently on that. Well, this little cap, as expected, I mean, matter of fact, let me turn this up. It just drains down ridiculous. And there's practically no noticeable frequency. You can hear it's just straight current. Now let me add as much capacitance as I can from this air cap. Try that again. That's a little bit too loud. So you can see as I turn the air cap up, add some capacitance, and when I close the circuit now it'll ring down. So it's ringing now. It's ringing as opposed to just straight current. This is still too loud. Let me try to get this down. Got my roommate trying to sleep, you know. All right. LED is still lit. Let me cut this light on. So the LED is lighting on down. So we're still getting a nice ring at around 0.5 volt. And then it finally cuts out about 0.4 volts. And we're not getting anything else out of it. No matter what I do with the cap or what have you. So what I'm going to do is cut this light back on. It's a little bright ass flashlight. So I'm cutting my capacitor all the way back down. And again, I'm going to charge my cap here. And what I'm going to show is how this circuit is all about capacitance. To get a very nice long runtime and that ringing that you want, it's pretty much all about balancing all your factors. You know, your voltage, your frequency, current, all timing is everything. There's definitely more professional ways to explain that, but basically this is the best way I can put it. So basically, I've got this capacitor here, I've got this resistance here, and then what I'm going to do is I'm going to grab onto this resistor. This is basically just coming off of one of my pots, my series variable resistance. So my voltage is slowly winding down from the cap naturally. I'm going to grab this, and I'm basically going to add some extra capacitance by touching this lead right here. Now this lead is basically allowing me to close the circuit on the base winding. It's helping bias the transistor to switch it on and off. And I'm basically just touching this wire and then putting my thumb on top of the rubber of the clip lead. And what that's doing is it's adding capacitance to the circuit just enough to get it going. Now what's interesting is in this situation right now I could fidget with those knobs on my pots and it's not going to do anything. You know, I could turn it all the way up, all the way down. It makes no difference. There will be no change in the circuit whatsoever changing those. Those might as well just be a straight wire. And I don't know if you can hear that on the radio. I'm just blinking away, right? my voltage. So now that you see what I'm doing, I'm going to cut this light back off so you can see the LED a little better. So I'm basically manually controlling the frequency of my circuit now, just by using my hand, the capacitance in my body, using my hand right now. So I can pretty much guide it faster and slower. I can bring it to a very slow speed like that. Now obviously right now if I move that air capacitor around, that's also going to drastically change it. But let's just try to, what I'm going to try to do is find a nice in between of a decent brightness and frequency. So you can hear right now. So for example, you hear the radio. So I'm getting somewhere in there is a good capacitance where you're going to get solid light from your LED. Okay. So this is 100 microfarad cap. Okay. In my experience, that should not be happening. It should not last that long. It's because we've got some great ringing going on. Now, let's just say I was to run the circuit like this. I don't have another free hand right now, so I can't actually adjust it. But just look at the drop in the cap. Now this LED, you know, the system might even be more efficient if I added more in series like Lasersaber has. This is literally the only LED I have right now. I had to steal it off of one of my little oscillators, which by the way, that's a Lid Motors penny oscillator on the left, and that's a variant that I made trying to match it, and they're pretty much identical, but neither of those come anywhere close to what this is doing right now. But anyway, if I had another hand right now, I would adjust that capacitor to add more capacitance, and that light is going to get brighter at not much of a cost of current at all. I wish I could show that, and it's not going to get really bright, but it will get brighter. Basically, let me put it this way: by doing what I'm doing right here and then adjusting the circuit with that air capacitor, it will operate extremely more efficient than were I to simply use the base resistance on potentiometers to adjust things. So what I'm doing right now is basically the witch's titties. So basically, if I was to get just the right frequency there, that's how you get that bright light from the LED, from the ringing from a small farad capacitor. Now, just to give you an idea, I mean, the run time down there is insane, and I'm sure this could be done better, but I'm using my hand right now as a throttle. So just to give a better idea, I'm gonna take. It sounded like it came back on too. Go ahead and drain that out. I'm gonna take and swap this out with the with this cap. And, let's see. This cap is the 10,000 microfarad, 25 volts. All right. So I'm gonna put that in there instead, which will give me considerably more runtime. So we still got about 4.5 volts in there from earlier. I'm gonna fill that up all the way. Now this one actually takes a little. It actually took a little time to get there. It's not necessarily an instant charge. That's why you got to find kind of a nice in between on your caps if you want one of those instant charges. So anyway, what I'm gonna do with this is I'm gonna cut the resistance all the way down, and then I'm gonna hook it up normally by adding this resistance on to the circuit, close the circuit. So that's running real bright. See that light? You just show you the rundown from just a straight hookup like that. Now my air capacitor is all the way down, and from this point, adjusting the resistance will get the light brighter. Bring it all the way up. Of course, it obviously drains the cap incredibly fast that way. And it'll drain on down, drain on down. But as you can hear from the radio, we're not getting any transients here. So I mean, this is pretty much just straight current. It's just sucking that cap straight out, which is, you know, nothing wrong with that. All right, now that we're down to 2 volts, let me mess with this and see what happens. So once I start adding capacitance, that's when I hear the radio start singing. And it's too freaking loud again. So we're sitting at 1.5 volts right now. Resistance all the way down. So now we're just draining this cap down from around 2 volts. The light is pretty minimal, but it's a solid non-blinking light either way. Just to give reference, I mean that's the kind of light I would see from my penny oscillator at a blink, at a low frequency blink. So to have a solid light that will actually run a little longer from a capacitor like that is actually pretty awesome. So adjusting the circuit with the air capacitor is what makes all the difference. And this is how I get it brighter and get it brighter or dimmer without killing the source battery or capacitor as quickly as using resistance change to get it brighter or dimmer. When I do that, which still doesn't, it still runs fairly efficiently, but see how bright we can get it. Let's go ahead and just drain that down. We're getting that full brightness. Now it's getting dimmer, dimmer. Voltage is really dropping down. Dimmer, dimmer, dimmer. Okay, so now, and I just brought it back up by changing the pot. And we're not going to get anything else out of this guy. Oh, just a little bit more actually. But interestingly enough, I wonder. So I'm actually able to squeeze more out of this cap. It'll actually oscillate down to about 0.2 volts, whereas the other cap would run down to about 0.4 volts. It's pretty interesting. So let's fill this, turn the resistance all the way back down, or all the way back up again. Fill this cap. Matter of fact, let's turn the circuit off. Alright, so we filled the cap again. We're at 9.5 volts. Air cap is all the way at the highest, or excuse me, lowest. It's all the way down, lowest capacitance. And I'm going to do what I did before by kind of throttling the circuit. So you see the voltage. Now, just to give you an idea of how long of a runtime I could get at a decent brightness, not just a really low blank off a cap this size, I'm going to try to find that in between like that right there. Okay. You can see how long, just to give you an idea, you can see how long it would actually run from a capacitor this size, about 10,000 microfarad. At that brightness. And it can get brighter. Even at that brightness, I think that's pretty damn impressive for how long it's looking like it'll run. I mean, we're not talking about hours or very long at all at this brightness, but it's a hell of a lot longer than I ever would have thought I would have been able to achieve. So this is pretty damn amazing. But if I bring it down to a barely usable brightness, like that right there, I say something like that right there is where you can read, just barely illuminate a pitch blackness or read from, and that will last you. I honestly don't know how long that will last, because I'm not going to be able to sit here and hold it like that with my hand. I haven't found a way to substitute this action yet with the actual components, which is the next step. But I would imagine this will give you a ridiculously long amount of light. And we're talking about a very small, cut this crap off, man. We're talking about a very small bobbin. So basically what I did with that bobbin was I wound, I want to say about 50 turns of 30 gauge on the inside, and then it must have been about 100 on the outside. So I was looking at about a 2-to-1 ratio. And I'm not entirely sure if this is accurate, but a lot of the reason why I say that is because the resistance on my base winding was about 1.2 ohms, while the run coil was about 0.6 ohms. So we've just been cranking this away. Still sitting at 8 volts. But if I was to let this thing blink mode like that at a frequency that your eyes can actually see the blink, this is gonna run down so slow, it's ridiculous. Like it's ridiculous. Like it's not gonna be something you can sit here and watch happen. But even so, for example, at this blinking brightness, which is hardly running down the capacitor whatsoever, I can turn it up with that cap, because as you can see, my capacitance is all the way down. This will get brighter by adjusting that cap, and it's not going to drop that voltage down at a very noticeable level at all. So you can see it's still teetering on. It hardly wants to drop. Let me see that 7 one more time. It's It's hard to explain if I was to see this at a lower voltage, but it almost makes sense because I'm sitting at 8 volts and I'm running a 2.5 volt load roughly, and I'm using um, spikes to do it. So I mean, at the end of the day, it's almost not really logic defying. It makes perfect sense, but it's just the method to actually achieve this was very confusing, and I'm starting to see the possibility that I could achieve laser saber like results. But we'll have to see. But just the fact that this was so simple was pretty amazing to me. I'm gonna keep playing with this, and I'm hoping I could figure out a way to emulate that without having to use my hand. And that way I could really this is similar to G Fusion Core, I believe, his video how his operated, but I'm pretty sure he had his connected up the same way Lasersaber did. So maybe his diode was just simply dead. I don't know. Maybe his diode was dead, and this is essentially what he was doing. Also, I don't know. It's pretty cool. Um, like I said, I'm gonna keep playing with it, but this is essentially was what I ended up figuring out, and I'm learning a lot. But just it's all about the capacitance across your base, your trigger winding. That's the name of the game. I'm sure it's ringing. I wish I had a scope that I could use to see what the wave looks like, but I'm sure it's ringing quite well. Anyway, this video's going on long enough, so I'll see what else I can figure out. All right, thanks for watching.